In part 2, this video will still be on section 7.1, but it will talk more about finding the actual probability of an event. So to start off with, we might want to learn a little bit more about what a probability falls under. So the probability will always be a real number between 0 and 1. So it can't be greater than 1. It cannot be a negative number either. The closer that probability is equaling to 0, the event will never happen. It's less likely to happen. Versus if it's closer to 1, the event is more likely to happen. It's certain to happen. If it falls right in the middle at 0.5, you're at 50-50. So there are two types of probabilities we're going to talk about today. The first one is classical, and that is when all outcomes are equally likely. So what does that mean, all outcomes are equally likely? Well, that comes up with like a deck of cards. There's hopefully always 52, unless you're missing a card or you've got some from another stack, but there should always be 52 playing cards. What about a dice? There's always that six-sided dice. There's always the 6 sides to it. So it's still the number of possible events over the number of outcomes of the sample space. But for it to be a classical probability, it has to be one that's known. Flipping a coin could be another example of a classical probability. You either have heads or tails. So suppose you were asked to draw a card from a standard deck of 52 cards, and you need to kind of have the following down in your notes, especially for quizzes and tests and homework problems. This has the layout. Some of you may know what makes up the 52 deck of cards, but it's okay if you don't. You have diamonds, you have clubs, you have spades, you have hearts. So there are 4 suits in a deck of cards. And each of those suits, you'll notice they have 13 cards that go with them, all the way from ace to a king. You may also see in your notes or in your homework problems, they speak of a face card. A face card would be like your jack, your queen, your king. So face cards would actually literally have the face on them. Otherwise, they'll say something like, what's the probability of drawing a 3 of diamonds? And that would be this guy up here. You're in the diamonds. There's only 1 3 out of those diamonds. You'll also notice half of these are red, half of these are black. So that'll come up a little later too about the different colors. So for our first example, we want to know the probability that the card you draw is red. So the probability of a red card, first you want the event, the number of red cards. Then you want the total number of cards in the deck. Well, the total number of the cards in the deck is what? 52 cards. But do we remember how many of those were red? I should be able to go back here. Right. So, adding up all the reds, you have 13 red diamonds. You have 13 red hearts. So what does that leave you with? 26 over 52. Or could you reduce that some? Because 26 over 52 just doesn't mean a lot to you. But when I reduce it to a half, that's telling me 50-50, right? I have a 50% chance or a 50% probability that the card will be drawn is red. Now for B, it's asking the probability that the card you draw is a diamond. So your event is the draw a diamond. So think about how you would set that up, your probability. Oh, sorry, I made a little 0.5 up there. Probability of a diamond. Well, you remember there's 13 cards in each suit, and a diamond is one of the suits. So 13 out of 52. Why 52? Because that is the total number of cards in a deck. That's why it's considered a classical probability, is because you're guaranteed that 52 standard deck of cards. 52 deck of cards. Or this 13 over 52 can reduce down to 1/4. In other words, 0.25. So you remember the first slide, it said if it was closer to 0, what did that mean if it was closer to 0? It was less likely to occur. Versus if it was closer to 1, what did that mean? It was more likely to occur. So the fact that this is a 0.25, you have a less likely chance of drawing a diamond than you did of drawing a red card. Because the red card's a little bit closer to 1, whereas this one's a little bit closer to 0. All right, so here's the face cards. The probability that the card you draw is a face card. So you remember the face cards are the ones with the king or the queen or the jack on them. So look back in your notes to see how many face cards there were overall. And there should have been 3 in each suit, and there's 4 suits. So there should be 12 face cards out of the 52. Still considered a classical probability, right? Classical probability meaning you know the total amount of outcomes. It's going to be 52 every time for the deck of cards. That reduces down to 3 over 13, which in other words is 0.2307, all of that. So it's a little bit less of a chance than it was to draw the diamonds. But it kind of makes sense. You only have 12 cards that you're looking for versus the other one was like 13 cards for the diamond. All right, how about D? Find the probability of drawing a red spade. A red spade. So that's a little tricky. Can a spade, first of all, which one was a spade? Looking back in your notes, it was one of the black cards. It kind of looks like a leaf. Are they red? Are they ever red? No. So there's no chance that they could draw a red spade. There is a 0 probability. Now you could put 0 over 52 to be standard to kind of keep it looking like this. But 0 over 52 reduces down to 0. So there's no chance you will ever draw a red spade because the spades are black, not red. Okay, calculating some more classical probability. So let's say we grab a bag of snacks. It contains 4 caramels with milk chocolate, 4 peppermints with white chocolate, 6 dark chocolate with mint, and 2 raspberries with dark chocolate. So what is the probability that you will randomly grab a raspberry with dark chocolate for your snack? So like I said in the first video, the first thing you want to know before you look for a probability is the total amount of sample space, your total outcomes. Well, you have 4 that are caramel with milk, 4 that are peppermint, 6 that are dark chocolate, and 2 with raspberries. So how could I find out the total amount of chocolates or snacks in this bag? Add them all up. So there are 16 snacks in this bag, 16 snacks of chocolates. And where did I pull this 2 from? The 2 came from the raspberries with dark chocolate. Why did I pick the 2 with the raspberries? Because we're looking for the probability that you randomly grab a raspberry with dark chocolate. So that's my event, the raspberry with dark chocolate. 16 is my total outcomes. And it'll change, I guess after they eat one of these, we will be down to 15 chocolates or so on and so on. But classical being you only have 16 in the bag. You don't have 17, you don't have 18, you have exactly 16 in the bag. Which 2 16s reduces down to 1/8, which reduces down to 0.125. So it's a very low possibility that when you reach into that bag, you will pull out a raspberry with dark chocolate. Because there's only 2 in that bag out of the 16. And you'll notice what I do over here with the P and the parentheses. The P is standing for the probability, and what's in the parentheses is telling me what I'm looking for, the event. So I wanted the probability of the raspberry with dark chocolate, so I wrote that in there to keep me focused with which one I'm looking for. If I wanted the probability of caramel with milk chocolate, I would have written that in there, so then I'm focused on caramel with milk chocolate. Empirical probability. So that's the second one we're going to talk about. There's only 2 probabilities we talk about in this class. It is calculated with the following formula. It looks very similar to the classical. You still need the number of times the event occurs, whatever special event you're looking for. But this time it's over the total number of experiments that are performed. So classical means you have a set 52 cards. You have a set 6-sided dice. You have a set of how many chocolates were in the bag. Experiment performed, you may have 10 experiments, 10 trials that you run, 80 trials that you run, 100. They change depending on what the event you're looking for, what probability you're looking for. So for example here, we have Libby. She was researching the accuracy of the weather prediction for her local news, and the table next will show her results for 2 weeks. So the forecast predicted rain, chance of snow, cloudy, and so on. And then this is actually what happened on that day. So Libby recorded what the news said, what the weather station said, and then she also recorded what happened on the day for the weather. And we wanted to see how many times they were correct, how many times the forecast got it right. Well, the first one's correct. They predicted rain, and it did rain. The second one, though, they predicted chance of snow, and they received rain. So that one was not it didn't work out. Like, it was a good prediction, but it was not an accurate prediction. It didn't actually happen. What about the snow and the snow? That's another good one. That actually did happen. So using that empirical probability, because again, this was just over 2 weeks, so many days, we need the total number of times the weather was reported for this case, and the total number of times the forecast was correct. So pause this video and look back in your notes to look at that, look for that table. I can kind of go back to it for a minute. Pause this video and check this table out and see how many times they recorded the weather and how many correct times it happened, how many correct forecasts. So looking back, she recorded for 14 days, because remember they said 2 weeks. And out of those 14 days, out of those 2 weeks, 8 times the forecast was correct, which reduces down to 4/7, which reduces down to 0.5714, and so on. So it was pretty close. It was about a 50-50. It was a little over 50-50 chance that they were correct. So the big thing to take away from this, empirical is the total number of times the experiment, or whatever they were looking for, was recorded, was tried. That's going to be different. You're not always going to have like the 52 deck of cards. But still on top, you're looking for the number of times of that event. So we wanted correct prediction. So we were looking for the number of times the forecast was correct. So that's the big difference between empirical and classical. Classical, you have a set amount of trials. 52 cards, 1 through 6 for a roll and a dice, heads or tails for flipping a coin. It's just very standard. It's cut and dry. It's like that every time. Versus empirical, where it changes depending on the investigation, the experiment that they choose.